So we're going to learn about installing ESX server and ESXi server, and then I will install the vCenter server. Typically in my previous classes, I used to do this only after the networking and storage and the virtual machines thing. Then only I get into vCenter. Probably this time I will take a different route. I will do the vCenter installation first so that we can bring in all our servers inside the vCenter, and probably then we can look into different properties and things like that from there as a single point interface rather than everybody connecting to individual servers. As I said, VMware vCenter server, it's only just the installation of it, but once we get the details of that vCenter server and all is going to happen after we learn about networking and storage. Networking and storage is pretty large topics. Virtual machines is also interesting chapter. There is quite something about understand about virtual machines, its files, its properties and things like that. Access control is about permissioning roles and all. We will look into that. Monitoring, data protection is backup, that we will talk later. Then comes to the high availability and scalability part of it. These are all the clustering aspects of VMware vSphere. So I will be talking and definitely teaching something more than what is inside this course. That is what I do. For example, some other monitoring tools, some disaster recovery techniques, and some other cluster properties, which is not in the official VMware course material. VMware course is actually divided into 2 or 3. They have a short 2-day course, and they have an advanced vSphere class, which talks about some advanced clustering properties and some other architectural based things. And then the normal VMware vSphere install and configure, that is this book. This is the 5-day course. This is what everybody needs: install and configure and manage VMware ESX server or ESXi5 or vCenter, whatever that thing. That is the thing. That's a 5-day course that is required. As per VMware, that is the main course. Okay. I also want to talk how many of, I think I did ask that question earlier, just to get an idea, how many of you have seen, physically seen or worked on HP servers? Just can you say who all worked on that? Please give a number. Anybody worked on it or not? Yes or no? Okay, Sujan saying you have seen HP servers, right? Okay.
Yeah, I did. Okay.
Okay. Byron, no. Fanny, no. Okay. Okay, so there are quite some people who didn't know.
I did work. This is funny. I did work on HP.
You did, right?
Yes. Okay,
so that's good. So let us talk about that also today, if possible. So I want to move faster. So here is the thing. So Fanny, let me ask you, what do you understand from this picture? This is an architectural diagram of a ESX server. I would say, architectural diagram means, it's a block diagram that explains the different pieces of an ESX server. So what do you understand from this? Can you talk about all these blocks and try to explain me what do you understand from it? Let's take each block. Maybe you can talk about this one block and then take this big block and then go into the smaller blocks. Let's see what do you understand.
Okay. First, coming to the physical layer, physical hardware. I see RAM, hardware components. All these are common for any physical server. So any HP or a Dell server, these are the regular components.
Okay, that's fine. So I'm just putting a hold on there. Okay, so let me talk a little bit. This is something I forgot, or maybe these are things comes into my mind, and whenever it comes, I think I should spit out. The 4 things that you're seeing in that physical hardware: memory, processor, storage, and networking. These four things are called as the I don't know, I have to mute you, okay? Okay, so these four things are called as the core resources. Core resources, when we learn later part of the thing, you will be coming across that. These four core resources. So virtualization is actually about dealing with these four things. How the virtualization software, which is nothing but our hypervisor, or now onwards I'm not going to talk about hypervisor, I'm going to talk about the VM kernel, because we are learning about the VMware's kernel. VM kernel, how VM kernel is intelligently manages these resources, these core resources, and how it manages that resources, and how it intelligently, or I don't know what the right word, how it efficiently provide those resources to individual VMs, so that the individual VMs does not feel that, oh, you know what, I'm not getting memory, I'm not getting a network, because somebody else is using. That's all an algorithm. I don't think we are going that level. That is probably the area of a VMware developer or somebody who actually designed this product. I don't think we need to look into that, but all we need to understand is that VM kernel is a very complicated, very complex software which does a lot of mathematical calculations, it do a lot of algorithms. So it do that calculations by itself, and in such a way that it will provide these resources intelligently and giving it to each of the VMs, so that the VMs will feel that they are actually talking to the real hardware. They are, or not talking to the hardware, they think that they have their own memory, their own processor, their own storage and network. That technique is what we are learning here, how this VM kernel is able to translate or convert that physical resources, the core resources, and presenting it to that VMs, so that the virtual machines think that, okay, they have the necessary things to work. Now, basically speaking, we are actually fooling the operating system. When I try to install a Windows 2003 operating system into a virtual machine, you know that the virtual machine is actually nothing but a real computer. It is not a real computer, it is actually a software. But the operating system is designed in such a way that when you start the operating system, there is a program inside that. Let us take Windows Server. When a Windows Server operating system starts, when the boot process starts, first thing it will check is whether you have a motherboard, whether you have a hard disk, whether you have a memory. What happens if your computer don't have a memory? Will it start operating? Whatever you are trying to boot, it will not start. If you don't have processor, it will not start. There is problem. So the VM actually fooling your operating system. Actually, your operating system, fooling means they are not like humans, right? They don't have any life. It's actually program. The program is set to check certain parameters. Okay, when you start, see whether there is a processor. So the VM is about to provide a software processor which emulates and show that, hey, you know what, this is not software processor, this is a real processor. So the operating system check mark that, okay, I have a processor, I have a memory, I have a network card. That's how you do it. So basically saying you are actually fooling the operating system, thinking that the operating system is running on a real hardware, but underlying the VM kernel is handling all these things. Okay, so when you get into the virtualization, and when we start learning about, or basically, I would say the whole class is more focused on these four resources. That's why they are called as the core resources. How intelligently VMware or VM kernel handles these resources and make the VMs use it, and how to, how it satisfies the VMs by providing these in an intelligent way. Let us say this physical server has 2 GB RAM. I'm giving a very simple example. Let us say this physical server has 2 GB RAM. Okay. And if that is the case, so how much RAM I have completely? 2 GB, correct? Can I give 1 GB RAM to all these VMs? Is it possible? No. Why? Because this is 4 GB, right? And then underlying hardware only has 2 GB. Is that what you're saying? Correct, right? That is what the problem, that is what everybody thinks. That is what everybody thinks. But that is not true. I can actually configure each of that VMs with 1 GB RAM so that the total RAM assigned to these VMs are 4 GB, even though my physical hardware only has 2 GB RAM. That is called, or that kind of a situation is called as over provisioning. Over provisioning is something that is encouraged by VMware. VMware actually tells their customers to over provision the resources, meaning you only have 2 GB, you give more than that. So you may be now wondering, how is it possible? Then if I have only 2 GB RAM, how is it really possible? We will learn and look into that in a later point. I'm just trying, but it is possible, and that is called as over provisioning. So VMware has intelligent algorithms, intelligent technologies built into the VM kernel to do that, all in this resource management. Now we're going to say all these as resource management as a single block, but basically VMware has intelligent technologies to satisfy these needs. And that is what we're going to learn when we get into memory management. I told you memory management is actually VMware has 3 or 4 types of memory management techniques. Same is the case with the processors also. Same is the case with the network cards also. I have only, let us just assume that I have 4 network cards here. I can configure each of these virtual machines with 2 network cards. Total I have 8 network cards, even though I only have 4 network cards. And this is why, so somebody was asking me, how is that possible? It's apple to apple. I was telling you, right, when we did in VMware, in Merrill Lynch, when we did that assessment, we see that 85% of our VMs are underutilized. They are only using 5% of the total resources. So you are basically wasting the resources all through the year. And that wastage is what is actually getting benefited here. These hardwares are made to use in full load. If you have a 4 processor, those 4 processors are supposed to work full time, 24/7 with its maximum capacity. There is nothing wrong with that. And that is how it is designed to. But unfortunately, in old days, you have a server with 4 processors, you use only 5% of that, and remaining 95% time it is idle. It's not doing anything. Today's world, people are all running behind bandwidth. Take a look at your own computer's network card. You can look at it. If you take your network card, go to the properties of your, go to the task manager and look at the network card of your server. See, you guys are using here. See, look at my connections here. I'm just using only these are all 100 Mbps connection. I think I'm looking at a different machine here. Let me look at this. Let me show you this particular server. This is my server where there are other connections are going on. Look at this networking. You are communicating. I'm trying to copy something. Let me try to copy something to. I cannot do that. Okay, I'm just saying. So basically, the network utilization is very, very less. So you are have a 1 GB connection and you are only using like 5%, 10%, 0.5%, you are wasting all the resources. That is where this is coming into picture. What happens if you run all the systems into 1 GB? That's a good question, and that is what everybody thinks. Okay, so that is a problem. So now I have 2 GB. That's, I know Sujan's question is based on this. I have 2 GB RAM, and how the hell I can run all these machines 4 GB? The first thing you need to look at is, in most of the cases, it's very, I mean, see, this concept is not just VMware's concept. You know, this is what every virtualization company is using. This is what Windows, this is what Hyper-V is using. But understanding the technology, we are talking about general technology in virtualization. Okay, it's nothing to do with VMware here. But every company has different ways of managing the memory management. Now, yes, that's a true question. If all of them are really using 4 GB RAM, then you may have problem. There will be resource contention for sure. I agree, but that chances are very less in a real big environment. All of them are using really that much. Even if they are using that much, there are other mechanisms which we will be learning. One of that is called the transparent page sharing technique. At that point, we will understand, or you will understand, how that is possible. I will talk about that when we get into there, Sujan. Okay, definitely there are memory management techniques to meet your needs. So we'll talk about that. Okay, so clusters and all. I think, Satya, now you are asking clusters. I understand your question. But I don't know what cluster you're talking about. I didn't talk about VMware clusters. So I don't know what picture you have in your cluster. You know, are you talking about a Linux cluster? Are you talking about a Microsoft cluster? Or are you talking about a VMware cluster? VMware cluster is totally different from the other clustering concepts you have in your mind. So when you say that, you know, I think I should not answer that now. So it's good you keep asking questions, but absolutely not a problem. But I think, you know, we will talk those things when we get into the clustering. That time you will have more questions. Okay. So guys, so I think, you know, so now Fanny, you can continue. So this is the core resources, and now let's get on to the next part.
Okay. Next, it's how do you communicate with these core resources? The VM kernel is how it's possible. So it has a stack, a TCP/IP stack for communicating with the NICs and the virtual NICs that you are creating, and for also for the storage, it tries to communicate with accordingly. The resource management, it's how you manage the resources for all the VMs that you have. The VMM, the virtual machine monitor, or virtual machine monitor, and the VMs, they both can be considered as just a virtual machine. All these will require the resources that you are providing from the physical side. So that is being managed from the VM kernel side. When you come to the service
Okay, yeah. That's fine. That's fine. Let me talk about that. So here again, you know, you said there is a TCP/IP stack and things like that. You know, that is first of all, you know, let's talk from this bottom layer here. So the VM kernel, if you want to talk to all these devices, you need to have the drivers. If you have a hard disk, you need to have that driver for it. If you want, you know, processors and memory also has some kind of drivers. You know, otherwise the operating system cannot understand it. So you may not normally see any processor. Oh, you know, I put a new processor. Do I have to install any driver for it? You might have never done that. But remember, believe me, every hardware requires a driver, and the operating system needs that driver in order to communicate. So there is a device drivers database itself is there, and using that device drivers, it talks to all these physical hardware. That is one block, and that is one topic, you know, device drivers. So I'm just talking about the block. So device drivers are something that's a very core important thing inside the kernel. If a device driver is corrupted, or if there is a problem with device driver or some mismatch, it could affect the performance, and it could affect, in fact, you know, accessibility, you know, to that accessibility to that particular hardware itself. So device drivers are very important. There are, you know, so whenever you upgrade whenever you upgrade your hardware, or whenever you upgrade the firmware for these device drivers, or the device drivers itself, because there's hardware manufacturers always release latest versions. You have to be very careful with that. You have to check with VMware, you have to check with the vendor. For example, if you have a HBA, a new HBA driver is coming, you may need to check with EMC, you may need to check with the HBA vendor, come on, I forgot the Imilex, or come on guys, what is the other thing? Anybody know Imilex, and what is the other company that makes HBAs?
Clarion?
QLogic, correct. QLogic. So, QLogic. So basically, you need to check with these companies, try to understand, the correct driver. Is it going to work with your version of VMware? These are all things are very important. Okay. So drivers, you have to be very careful with it when you're doing. But normally, you don't need to do anything. But I'm just saying, in future, or at a later point, sometimes there is a need for you to upgrade a driver. You may have to look into that. Now, when it comes to then we are getting onto the networking stack. I told you networking stack, network stack. Network stack is where all these, it's not just the TCP IP. There are other aspects to it. The networking, the whole switching, the virtual switch properties. Everything is inside that network stack. So Fanny was saying, there is a TCP IP stack. That is what it uses to talk to all this hardware. That's not true. TCP IP, there is a TCP IP stack inside the VM kernel. TCP IP is used for network communications. So VM kernel uses the network stack to communicate to other ESX servers and other infrastructure services. For example, you have a DNS server in your network. If the ESX server wants to do a name resolution, or it wants to access a FTP site or something, it uses the TCP IP stack or the TCP IP protocol inside the network stack. So think it in that way, not that VM kernel uses TCP IP stack to talk to a VM or a hard drive. That's not correct. Okay, it uses the device drivers to talk. Correct, Fanny? So the TCP IP stack is for the actual TCP communications, okay, not for talking to this hardware. Clear? Virtual NICs and switches, that's another thing. That's a feature inside the VM kernel to create virtual switches. And that is why I actually took this paper here. So here is the thing, just look at this picture here, guys. So this is, this picture, I'll be talking about this in later when we get into networking. I just wanted to show you. So this is the picture of a VMware ESX server. This is actually the VM kernel, the blue part. And next page, if you go, you can see that the networking, the VM kernel is here, and these are the physical network cards. Physical network card. This is not inside the VM kernel. These are the physical network cards on your hardware, and the physical network cards are actually connected to a physical switch. Correct? You have to do that. Your physical network cards of your server needs to be connected to a physical switch. What are we going to look into is we are going to look into the software side of it, or the networking piece inside the VM kernel. Okay, I'm going to show you next picture. Look here. This is actually, what is this? Where is this? This is a switch, but it is a virtual switch. That means it is a software switch which is inside the VM kernel. So you don't see it physically, but when we draw pictures and all, or if you go to a server like this, you're going to see a switch like this. You will be seeing something like this. This is a switch, but it is a software switch. But here they are, graphically they are representing that. But actually, you need to understand is what is this switch? This is a switch. The name of the switch is vSwitch0. The switch has so many connections. It is connected to a physical network card. See, this is a physical network card like what I was showing. This is the physical network card. So this is a virtual switch. This virtual switch can be connected to all of these NICs or one of the NIC, whatever it is. But that virtual switch is what we are talking about. You're getting what I'm saying? So it is picturized there, but it is actually a software feature. which is VMware's own technique. Every company has their own technique. So understand in that way. You have to think, make your thinking in that angle. This is a switch inside the software. So it's not actually a physical switch. It is nothing. It is a software. Okay. But we are graphically representing that. And then we will learn and see, you can see that the virtual switches are connected to a physical switch, and that is exactly we are doing here. This is a virtual switch. All this is, let me take a pen and show you. This whole thing is a virtual switch. And this virtual switch is attached to a physical switch. This is the physical switch. Okay? We will come back and learn about networking later, but I'm just showing you to clear your thing. These blocks and these things means they are software pieces. There is nothing physical here, but try to understand. Something the same thing, when it comes to storage stack. So storage stack is actually contains a lot of storaging technologies. We need to talk to, I told you, when we learn about storage, let me do that also. Let me show you. I have another document which probably I could show you. There is a ESX 3.5 document which has that picture clear. Let me see, I can find that document. I'll be sending you all these documents, okay, don't worry, tomorrow you will get all these documents. Okay, I mean, just look at this picture. We will be looking into this. We will talk about all these things. This is actually a fiber channel SAN arrays thing. We will be going through all these pieces. Those who know storage, they know what it is by looking itself here. We will be going through all this in detail. But what I'm trying to tell you here is this is actually a fiber channel SAN storage, and these are fiber switches and things like that. You don't need to worry about it. But these are your ESX servers. The ESX servers will have, I don't know, you can see me. So these are called HBAs, or these are the things that you use to connect to the storage. Now, this has its drivers, and then it also needs some technology to understand or talk to these SAN storage. Without that, it cannot talk and understand this technology. This is fiber channel SAN storage. It uses fiber optic techniques. It uses fiber channel protocol. That's a totally different protocol. It's not TCP/IP protocol. It's a totally different protocol. The VMware ESX server, if it needs to talk to a fiber channel SAN, it needs to understand the fiber channel protocol. So those we will learn, but that is what this storage stack is having. This storage stack contains different type of techniques. That is how an ESX server is able to talk to different storage technologies. See, when I say ESX server, these things are all applicable between ESX and ESXi, no difference. Everything will have the same thing. Whether it is ESX or whether it is ESXi, all these things are exactly the same. Then from the storage stack, when you access to a storage, when you get some hard drive or hard disk, then you can format that storage and you can create your file system to store virtual machines. I told you yesterday, BMFS file system. BMFS file system is the file system that you need to keep virtual machines. Virtual machines can only be created in a BMFS file system. You cannot create VMware virtual machines in an NTFS file system or an EXT file system or any other file system. It can only be created on a BMFS file system. There is an exception to it, which I will talk later. Resource management this is a block. That means we have to see, do we have to create a virtual switch? Sure, Sri, we have to create a whole lot of switches. We will be learning. Now, switching is very important. That's a topic. That's why 3 days is needed to finish that switching. We have to create different types of switches, different standards and all those things. We will be doing that in the coming days. Yes. Not one.
I was thinking without a virtual switch you can still run, right?
No, without a virtual switch you cannot. You cannot create a VM. That VM cannot. You can create a VM, but that VM cannot communicate.
But you already have a NIC that you have to create a virtual NIC out of it.
Explain that.
Like I say, you're presenting your NICs to your hypervisor, which is VMware, and then when you create a VM, you can create a virtual NIC out of it, right? Or
You can create a VM. You can create a VM. Okay, that's a good question. So let me. That's a very good question. Okay, I mean, that this is how the thing. This kind of questions makes others also understand. Good. So let me explain this. So you see this particular picture here. Okay, this is networking. I am not supposed to come here, but since you asked me that question, and these are two VMs. You agree with me? This is a Windows 2003, and this is a Red Hat thing. And these VMs has their own virtual network card. Okay, let me take this pen and show you. This is the virtual NIC card of this VM, and this is the virtual NIC card of this VM. Are you agree with me?
right.
This is on the top of this. These VMs are, where is it? They are sitting on top of the VM kernel, correct?
Correct.
Because that's where you create your VMM. A VM is nothing but VMM. We learned that from that other block diagram. So this is that VM. Now you have a network card here. So now are you asking me a question that can I attach this to a NIC card? Can you attach one NIC card to another NIC card like this? Is it possible?
No, not that way. I was asking.
Okay. So you need.
I was trying to eliminate the virtual switch. So
You need to have a virtual switch. So what I'm trying to tell you here is you have to have a virtual switch to connect your virtual machine to the outside world. So let us say I have a computer here in the outside world. This is a physical desktop, and Deepu is sitting here. And if I want to talk to this VM, my computer is connected to one of the port of this switch. Correct? So this is my computer, and this is connected to this port. Now, if I want to talk to this VM, the communication will go like this. It will go through here. It will go through here. It will go through this network card. It will go through here. It will go through here. It will go through here, and it will access. You see what I'm saying? So, intermediate, you have to have this virtual switch to do that communication. So, answer to your question, without this switch, you'll never be able to talk to the outside world. Not only outside world, you cannot even talk between these two. You have to have a switch. Even though both are in the VM kernel, if you want to talk to between these two VM, you still need to have a switch. We will learn about switch. We will learn about all these port groups. That's all very important topics which we will talk later. I hope I answer your question, right?
Yeah, but I was just comparing with Zen server, so no worries.
I'm sorry?
I was just comparing with Zen server.
Okay. Yeah, I'm not. I don't know much about that.
That's why I didn't bring the topic. I was just asking. I didn't have to do a virtual switch there, so.
Right. I mean, I think in any technology that switch has to be there. Otherwise, you cannot talk. I don't think it is possible otherwise. But we can talk it offline otherwise. Okay. Thanks. So resource management, I'm not talking about it. Resource management is the thing that talks about, 2 GB RAM, giving 4 GB RAM, only 4 processors. How can I give 20 processors? I only have one network card. How can I give each VM 4 network cards? I have only this much storage. How can I give, there are thin provisioning, thick provisioning, whole kind of things we're going to learn when we get into storage and things. So resource management deals with the resources, which deals with the core resources. When we talk about the core resources, you can divide that core resources into 2 parts. One is called as the compute resources, and the other one is actually the storage and networking. Compute resources, whenever you see someone talking about compute resources, that means the computing, the calculation resources, that is the CPU and the memory. Okay, when somebody say compute resources, that is 99% they are talking about memory and CPU. They are not talking about network and storage. But when we talk about core resources, all the 4 are important. But out of the 4, I would say the most important are the 2 are these compute resources, which is the memory and RAM. Without that, a VM is, it cannot even exist. All right. So now coming to Raiden's yesterday's question. So what is this? Before going to service console, let me talk about it. So a VMM is not called as virtual machine monitor. I showed you how to create a VM. A virtual machine monitor is actually called as a VM or a virtual machine. It is actually that shell. That shell contains nothing. It is like a a brand new computer without any operating system. It will have memory, it will have CPU, it will have a motherboard, it will have a BIOS inside it, it will have a hard disk, all those things, but it will not have any operating system. And that is actually a software. Who creates that software? That small piece is created by the VM kernel. So when you create a VM, actually VM kernel will make this VMM for you. Now once you make this VMM, or once you make that VM, you can install your choice of operating system inside it, or the guest OS inside it. So a VM is nothing but a software which is created by the help of VM kernel. So it's basically the VMs are sitting on top of the VM kernel. VM kernel creates and manages it. Okay, if all the communication, if you want to power off a VM, VM kernel has to send that signal. If you want to power on a VM, VM kernel has to talk to it. You cannot talk to a VM directly. You may think that you are talking to a VM directly. For example, here I want to start this VM. This is a VM, correct? This is a virtual machine. So I can open the console here and show you. This is currently powered off. I can power it on. If I click on this power on button, don't think that, oh, okay, I'm powering on the VM. But what I am doing actually is this. I am sitting here. Let me take a thing. Understand this. This is very important to understand. I am sitting here in my desktop, in my office. I have this desktop and I have this VMware screen, all those things. But when I say power on a VM, let's say I'm going to power on this VM, what exactly happens is this. I am sending a message from my PC to the service console, which is the management interface for a ESX server. That message will come through here and I will tell the VM kernel, hey, you know VM kernel, go and power on this VM number X. Then the VM kernel will power on your VM. You getting what I'm saying? So if I want to communicate to a VM, power it on or power it off or reconfigure or anything if I want to do, I have to talk through the service console. So service console is actually your management interface, which is nothing but a Red Hat Linux software, which we will see. If you don't understand it, don't worry about it. When I do it, I will show you. So this is actually a Red Hat Linux operating system running inside this VM. This is a big VM. That is why I called you that it is called as a mother VM. This is same. This is also a VMM, guys. This is also a VMM, but it is a special class VMM. Special VM means it has certain priorities over the other ones. Meaning VM kernel always make sure that it will get certain amount of memory. VM kernel always make sure that the CPU 0 means always the first CPU. The first CPU is always assigned to that. No matter what, whether these VMs take these CPUs, all the CPUs or not, VM kernel will make sure that let these guys use all of them, but this first CPU will always be given to the service console. Why is that? Can anybody tell me? Why the VM kernel is so much particular about that mother VM? Okay, booting. I don't understand that. Any other answers? Controller. Okay. Any other answers? That is the correct answer because that's the correct controller. I think Sri, you mentioned that same thing because that is the controller. If you don't have that controller, you cannot do anything to an ESX server. You cannot do anything. So it is absolutely necessary that a service console has to be there. If something goes wrong with the service console, you cannot manage an ESX server. So that is the importance of that. So a service console is nothing but a customized version of a Red Hat Linux, and then it has a certain box inside it. That is all different management things. You can. I told you yesterday. If you want to monitor HP hardware, this is an HP server, and I wanted to monitor the hardware. I can install an HP agent inside this server. If I want to write some SDK agent, basically it's for backing up. I can write some, let's say, net backup or ComVault or EMC's Avamar or any other backup technologies. They wanted to talk to this VM kernel and want to back up this VM. Or let's say to back up the whole kernel itself. These SDKs or these kind of software APIs can be used to talk to it, but the APIs has to be installed on the service console, not on the VM kernel. In an ESX server, you don't install anything on the VM kernel. VM kernel is very reserved place. It is meant for these purposes only. If you want to install something to monitor your ESX server, if you want to install something to back up your VM, or you want to do something with your ESX server, you install it on your service console and do it, not on the kernel itself. Or you don't have a choice. There is no option to do that. That's the key. Okay. So that is this architecture diagram. Let me take a step, one more step. I want to move fast. This is, I'm repeating the same thing stuff here. One more thing. So that is that picture. Okay. Hold on a second, right? Okay, 1 minute. Where is that ESXi picture, man? Okay, go ahead. You ask your question. That's correct. That's what I'm going to talk now. Okay, so this is the ESXi picture. Now let's talk about this ESXi picture a little bit. See, guys, understand one thing. I've been telling from day one, and even yesterday and today, I'm again repeating. There is absolutely no difference between an ESX server and an ESXi service. The kernel side, hypervisor wise, they both are absolutely same. So what is different? The way you manage an ESX server and an ESXi server are different. So what has happened is, this is a Red Hat Linux. VMware has to pay a lot of money and things like that. Now let me. I think that this is the best practice. I don't know, again, these numbers I'm going to tell you here is not correct. Okay, believe me, it's not correct. It has changed a lot, but I'm just trying to tell you here. I think, this is, I'm talking from my old concept, whatever is in my memory. And this is how it is. A VMware ESX server is typically around this much in size, which is, I would say, around 700 MB. This is an ESX server's total binary. I mean, it's not correct, okay? I'm just giving an example here. You may have to read that book to find out the correct size. In that 700 MB, this much, the green side, is what? Is actually the service console, which is nothing but around, I'm talking about around 550 or 600 MB. Let's take 600 MB. 600 MB is the Red Hat Linux. And the remaining 100 MB is what? VM kernel. So this is what it is actually. An ESX server binary, if you take, it is around 700 MB. Again, don't take these numbers. I think you have to read that. I forgot the numbers, but we can find out. This is how it is. A VM kernel, actual hypervisor is only this much, which is nothing but, guys, it's only that small 100 MB. It's not even 100 MB. It is less than that. It was 53 MB or something, if my understanding is correct. That is all it is. It's a very small, thin layer of operating system. I'm sure it's not 100 MB. Okay, it's less than that actually. But now, it's been improved a lot, but it's changed. But the size is something like, you compare it like this. for your understanding. 1.7 GB, yeah, that's all, Fanny, that's all from different, other things. But, I understand that may be correct. 150 MB is and 1.75 GB is the size. Okay, but I'm, little, that's correct probably. I'm not arguing that. This is what an ESX server is. Now, what is the size of an ESXi server? ESXi server is only this much. Probably, like Fanny said, 150 MB. It is not little more than that. So I'm saying, what is difference between here? ESXi do not have this service console. So first itself, VMware, by getting rid of this service console, VMware was able to make their binary to that small 150 MB now, instead of a 1 GB size. They were able to reduce that to a small footprint, which is a big win for them. Now, that is not the main problem. The main problem, if you know that, if I know that, I'll explain this. In VMware, like Microsoft, Microsoft releases Patch Tuesday. Every second Tuesday, Microsoft releases patches. You're all familiar with it. You might have all see these are all patches pending on my Windows servers here. These are all my Microsofts. It is pending for installation. All these are Microsoft patches waiting here. Every Tuesday, Microsoft releases. Same way, VMware also releases patches, but not on every Tuesday. VMware release patches, I have seen sometimes there is no patches coming out for a month or 45 days, but then I will see there is a flow of patches. There is no specific like Patch Tuesday for Microsoft, VMware, but they do release patches. And at least I've seen that they release patches once in every month or sometimes twice in a month. We will be learning about patching, patch management, update manager. That itself is a huge topic. It has a database and all. We will be learning that at the later part of the class, how to manage that, how to upgrade that and all. But I'm trying to tell you here is, out of, let's say, June 2012, VMware released 15 patches for ESX Server 4.1. 15 patches were released by VMware for ESX Server 4.1 for the month of June 2012. Whereas they released only 3 patches for ESXi 4.1. Why is that? The difference is that out of the 15 patches, 12 patches were for patching that service console. This is a big problem, and that is because that is one of the biggest security threat for VMware. I mean that's a operating system widely used by the industry. Hackers target that. It is very obvious. So VMware has to come up with patches and bug fixes and all every month for Red Hat Linux, 10 times more than what they need to patch for their hypervisor. And that was one of the main reasons why they wanted to get rid of the service console. Service console had some advantages, like what I said, third-party agents and things like that. But they really wanted to get rid of that. Now, Fanny was talking the other day, Hyper-V. Hyper-V, Microsoft has that pain. Definitely, Microsoft has to make sure that they patch that Windows 2008 core. It is a Windows operating system without a graphical interface. And then Microsoft has their own hypervisor that sits under that. The hypervisor may need only 1 or 2 patches. But Microsoft has to put more concentration and more effort to patch that Windows operating system. You getting what I'm saying? So that is the problem. That is what VMware achieved by getting rid of this particular service console. Once the service console is gone, the number of patches are reduced. The risks towards hacking and other things are reduced. The total footprint of the whole thing is being reduced. You don't even need a hard disk to install an ESX server. You know that? There are many companies, and I didn't talk about that, which is not very important, but since these are things that are coming to my mind, I'm telling you. again, let me explain. There is another version of an ESX. There is another version of an ESX. So there are two types of ESXi. ESXi has two variants. One is called as ESXi embedded, and the other one is called as ESXi installable. What we're going to use in our class and what we will be learning is all going to be ESXi installable. ESXi installable is a version of the ESXi that is what commonly used, which you can install on a hard drive. Again, it's only 150 MB. So you don't need a hard disk. You know that the smallest hard disk you can buy from HP today is 146 GB. There is no more 32 GBs and no more 72 gig hard drive. Those days are all gone. The smallest hard drive you can buy from HP is 146 GB. And you need only 150 MB to install your so-called VMware hypervisor. It's a waste of space. But you can utilize that space, but that's a whole different story. You will understand that why I'm saying that waste of space once we get into the clustering and all. Okay, sorry guys. So there is another version called ESXi embedded. ESXi embedded is a technique that VMware uses. You can get your ESXi operating system in a thumb drive, a pen drive. You just boot from your USB pen drive and you're gone. You're good. Your server is up and running. HP, IBM, and Dell are shipping servers with embedded versions inside. There is a USB stick inside the motherboard. You can see that if you open the case of the HP server or IBM server, you can see that inside the motherboard there is a small thumb drive which is there. In that case, it's called as ESXi in a box. You buy that HP server, rack it, connect the cables, power it on, ESXi is booted. Everything is inbuilt, already pre-installed. It is coming from that small embedded thing. So it is possible. There is also options where you can boot your ESX server from the SAN itself without hard disk. So in our office there are ESX servers that we use to boot from SAN. You don't need a hard disk at all. I will talk about those things later. But just if somebody asks you, you need to know about what is ESXi embedded and what is installable. Embedded is something that comes in a thumb drive, and the installable is the normal installation. But anyway, either case, it is only 150 MB in size. Okay, so this is ESXi. I would say ESXi is little bit, it's a little bit more. This is what it is. So now, what is the difference between this picture and this picture? If you look closely, you may see some other stuff which I explained that day. It's basically the blue thing is equivalent to the orange thing here. The only difference is here you can see that there is no service console. In this picture, there is no service console. So how do you manage an ESXi server? So what VMware has done is, VMware has improved their kernel a little bit more. The networking stack has improved, and some other new features were added into the kernel. And one of the main features they added is actually called as the VMware Management Framework, which is a set of software which will allow you to communicate to the VM kernel directly without the help of a service console. There is a small web application, Apache web server is running here. There is some other pieces are also inside this, which will allow you to talk to this. They also have a small module called Common Information Model, which is a generic terminology. It's a international standard SIM model. Anybody know what a SIM is? Anybody heard about SIM? common information model. That's a standard. It's not HP SIM. HP SIM is a total different thing. Okay, that is Systems Insight Manager. This is CIM SIM. This is called as common information model. You can do some Googling. I recommend you to do some Googling of that. Try to understand what it is. I'm not going to talk about that. Is actually used for managing the hardware. So agentless hardware monitoring. Earlier, you need third-party agents, your HP SIM agents and all you need to install here on the service console, and then you have to manage the hardware. Now you don't have that service console, but VMware provided something called as a common information model, wherein your agents can talk directly to this model and can get information from the hardware. Let me see, I can show you some information here, probably here. If you look at this thing, I can show you here. If you look at this ESX, this is an ESXi server. If you go to the ESXi server, in the health status, here you see that it can tell you the processes, it can tell you the temperature, it can tell you the fan. How is this ESXi server able to see the fans of your hardware? How is it able to detect the power? See, it says that one of the power cord is off. And that is why I am getting that alert message here, because one of my power supply is down. So it is happening, or the ESX server is knowing that through this SIM model. It is able to talk to the hardware using that. So the VM kernel has been improved. There are some software pieces they were able to embed it inside this VM kernel to do that. So that is not there. This SIM model, this VMware management is not in a ESX server's kernel. All those things are inside the service console. Now that they get rid of the service console, they have to do those things anyways. So they added those features inside this. Okay, like that they added some other features also. For example, NTP. Anybody know what is NTP is? It is network time protocol. That is a protocol that will allow you to talk to the time servers and get your server synchronized with time. We will learn that, I will show you how to do that. NTP was earlier a part of service console. Now you don't have service console, so they created some NTP techniques inside the service console. Okay, so guys, that is the difference. So this is, I think you got an understanding of what an ESX server and what an ESXi server is. I think there is no meaning in spending more time here. This is what it is. So you understand the difference between it, both from an hypervisor perspective. When you talk about hypervisor, means from a virtualization perspective, both of them are absolutely same. The only difference is the way you manage are different. Okay, that's it. I think then you are clear on that, right? Okay, now what I'm going to talk is, well, I'm not going to talk. Let us now get on to certain hardware stuff. I quickly wanted to give you guys some impression about some HP servers and some servers. I know most of you are already aware of it, but I think this is something I do in my normal class as a practice. So now, for example, let me, okay, I'm going to my main desktop. You may see that my sound will be breaking, things like that. Don't worry about it. If it goes, it goes. Okay, I'm not going to disable my antivirus today. What I'm going to show you here is something here. 1 minute. Okay, this is one of my students' resume. In that one resume, he is talking about hardware. He is talking about all these hardware. This guy's resume, he is talking about all these hardware. Dell PowerEdge 2800, 29. If that's the case, let me ask you guys here a question. Type in at least few server models. You are claiming that, or you are going to claim that you are a VMware guy, you know VMware for 6 years, you've been working with major big projects and stuff like that, and that is why you are asking Deepu to give a job in your village. Okay, fine, I will give you a job. I'm asking you a question, okay, what are the server hardware you are familiar with? Fanny, give me some server models you are familiar with. Anybody, whoever knows server model, please type in, okay, DL380G7. Okay, DL380, 580. Okay, give me the models little bit more. 380, 580 is not enough. Give me the models you have worked on. Okay. G3, G4, G5. Okay. Okay, G4 to G7. So, people who know Sri and the Gene and all, they know it. But others, they're not typing. So, guys, when you talk about servers, there are different models. And at least you should know 3 models minimum. Minimum 3, I would say, because you cannot say that I know. And if you go and say, I know DL380, G380 or 385, and if you say, oh, what model, what generation, and if you say G15 or something, gone. Okay, so don't lie there. So you have to know it. If you try to lie, I work on the latest 385 G1 or something. If you say 100%, you know that you are lie. So I'm not asking you to learn about all lot of things like, he knows it. Cisco, UCS, Dell, Blades, that things. You don't need to go that far, but at least you should know 3-4 models of HP, 2-3 models of Dell. If you are interested, Cisco has a whole series of new, UCS Blades are coming. You can go there and take a look at it and try to understand something. So, so that's all very important things. So let me take you quickly for a thing, this is for, the guys who don't know server hardware, and my servers are all HP servers, so I just wanted to take it. So what you need to do is, I'm going to show you HP site. All you need to do is go to hp.com. I wanted to take this in 10 minutes, okay? But this is up to you. You guys do your homework here. I'm just showing you some ways to go and explore the things, those who don't know. When you go to HP site, you basically, what you have to do is you have to go here, and then you can see here large enterprise businesses. Click on the large enterprise business section. And go to server. Okay, now you go to the HP server session. When it comes to HP site, guys, give me a second. Okay, where is this chat window? Okay. Okay, can you hear me? My PC is buzzing actually. Okay, good. Okay, so when you go to the HP server side, HP has different server models. I mean, those who have worked with HP servers over the period probably may know most of their servers, but they have mainly 2 types of servers. One is called as the ProLine family, and the other one is the integrity systems. These are, I'm not familiar with this. These are also servers that are used in some high-end servers, but mostly the ProLine servers. When it comes to ProLine servers, there are mainly 3 types of ProLine servers. BL servers stands for Blade servers. DL servers are, oh, I forgot that name again. DL means, every last class also I asked my students to Google for it. DL means,
rack servers?
No. Yeah, they're all rack servers. Google DL4 something like. It's actually down something. I forgot that. DL means data link. DL is data link. I think not data link. There is something else for that actually. Let me see. Yeah, density line.
Density link. You can say density link.
Yeah, density line.
Density link.
ML means medium line or something like that. Okay, I forgot that. So density line servers. That's the name of it. Okay, guys. Okay, so density line servers and ML servers. Again, I think you don't need to. I'm not going to talk about all these things. So let us go into the DL server. These are some of the most common servers. You can see that Sri and Fanny, they were all typing more of DL series servers. When it comes to DL series servers, they have different servers. They have 100 series servers, 300 series servers, DL 500 series, and DL 900 series servers. The price of a server depends on the size and the memory. So typically, you can see that companies are using DL 300 and 500 series. I'm not going to the 500. 500s were used heavily in old days, but nowadays the 300s are so powerful because the multi-core technologies and all are very popular. So a lot of companies are using a lot of DL 300 series, unless otherwise for some large database servers and all, I see people using 500 series. Okay, thanks, Fanny. Maximum expansion, that is called ML series servers, and scalable line. Okay, I forget all these things. Even next time, I don't know. Sometimes it's like that. So 300 series servers. I don't want you to go here or here. Go to the 300 series servers. When you go to 300 series servers, you're going to see a lot of servers. These are all different type of servers from HP. The latest ones, the old models are not here. So you can see that they have something like 360, then comes to 360 G7, 380s, 385s, 320, 370, things like that. So these are all different servers. So look at here, this is a DL380 G7 server. This is how it looks like. My servers, most of the, half of the servers looks like this. Or these are called rack mount servers. And you can see that the pricing starting from $2,000. Don't think that you get a server for $2,000. Once you start adding memory and processor, the price can go up to like 10,000, 12,000. Today actually in my office, I provisioned a server. The total cost of that server came to $200,000. The reason is nothing but the server. That particular team, that was for our ETL Informatica processing team, they wanted to do some large conversions on weekends. And they were demanding 10 terabytes of solid state storage. And that whole price, the $200,000, $150,000 were used for purchasing that solid state drive. So I'm just giving an example. So depending on your hardware, you need to know the price will go up. We would need to get familiar with all of these models. Don't get scared. You don't need to do all of it. I will tell you what to do. A few of them you need to definitely. You don't need to get familiar. At least you should mug up or by heart these names so that you can present it when you go for interview. This is how a server looks like. You can go to some Google videos, or if you can come to my house, Raiden and all. You guys are new up. If you want, you can come over. I can show you, open it, and show you all these servers if you are really interested. I always encourage students who are near to my house. They can come and see it. Otherwise, I don't have a choice. But those who are familiar with, you know it. So these are servers. I will show you some more stuff. So this is a DL380 G7 server. Now, when you go to this is actually, I came a little bit inside the site. When you come here, there is something called QuickSpec US. Click on that link. That will give you some more inside details about your server, the inside picture and the back. This is the back side of it and every part of it, what is there and all. And these are the different type of processors in this thing. See, for example, this server model can support 6-core processors. It can support quad-core processors. And again, the processors are of different speed. You can see that 3.3 gigahertz 6-core processor. 3.4 gigahertz, 2.4 gigahertz. They're all different processors from different Intel families. And if you look at all these things, you can see that these are all Intel processors. Okay, and then comes to the memory, everything. So yeah, eBay will show probably that. You can go to eBay and you can buy also servers. These ones are actually for very cheap price. So one important thing I wanted to tell you here is, this is very important, and that could sometimes an interviewer ask, and if you don't know the answer, it's a problem. Some of the servers has a number called ending with a 0, 380, 360, and some of them are ending with 385, 365, like that. I know some of you know the answers. Who all knows it? What is that means? What is the difference means? Anybody know?
One is Intel, one is AMD.
Okay. Anything, this is common across Dell and HP. Okay. If your number is ending with a 5, that means that server is having AMD processors. If your number is ending with a 0, then that server is running an Intel processor. This is a universal rule, no matter what. You don't get a server with that. If that's the case, what is the processor inside the server? This is a DL385G2 server. It's an AMD server, and you can see that it's right here. It's saying dual core AMD. What is the case in this case in this server? This is a 380G3. You can see that it's an Intel server. You see that? So that's how the difference is. So if a number ending with a 0, it is Intel, and if it is ending with a 5, it is an AMD processor. Okay, very, very, very careful. So the thing is, the latest model servers from from HP are actually called as the Generation 8 servers. They are called as Gen 8 servers. Actually, you can see that. I'll tell you a funny story about this. It is actually they are called as these are all called as G7s. So I know Sri was writing earlier, G4 to G7 he knows. Or somebody else was telling G1, G2, G3. You've been hearing. G stands for generation. But when it comes to the latest version, I don't see any G8s. It's only Gen 8s. Anybody know why is that?
I know. G8 is a bad word in Chinese.
That's correct, man. So you got it. So actually, that is actually a very bad word in Chinese. I don't want to say that. G8 is actually not a good word in Chinese. So that's why, but people still say G8 though. But that's why AMD, that's why HP specifically put them as Gen 8. But it is actually, you can call it as G8. As long as you are not in China, I think you will be okay. Okay. So, so that is the thing. So the newest model servers are these Gen 8 servers, and they are actually coming up with the latest Sandy Bridge processors, and all these servers are already started shipping. We got actually 2 or 3 batches of the servers, so now we are actually doing some engineering work on these servers. Yet to start using production yet. We are still using G7s for our production builds. So G7, G8, G6, G5s, they are all probably good. I think you don't need to go beyond G5s with respect to Intel servers. I think anything older than G5, I would say G6 itself is old, probably 3 years old. In the case of AMD, actually they had a G1. There was no G1 as such. It was the normal model. It was called as a DL385. Then they came up with a Generation 2 server. There was no G3, G4 and all were there, and then they moved actually to DL385 G5. So 385s, I would say the latest ones. If you are planning to buy something, go for something with G5 and above. Don't go and buy anything older than G5s. Okay, so these are some servers, DL servers, DL series, 300 series servers. If you go to 500 series, you can see some more bigger servers. again, you can see that the new 580 G7s, 585, AMD, and see here you can see AMD. These are 4U servers. That means their height is double the size of the other ones. The other one DL380s are 2U servers. U stands for a unit. That's how you measure the servers when you put them on the rack, or in a data center terminology, it's actually. So 2U servers, 4U servers, 8U servers, things like that. So these servers are important. So I think you may write into your question. Definitely by heart these two numbers, DL580 and 585 G7s, and at least a few names from the DL300 series, at least by heart something. Same thing is applicable to Dell also. If you go to Dell, you can see that they have some new R7 and things like that. There are some servers. I'm not very familiar with Dell servers. I worked on it a few. We have few servers here and there from third-party customers, but other than that, on my office, we are purely a HP shop. So take a look at the HP site, Dell site also, and look at least there are a few models. And put it on your document. That is how you are able to put it here. When you put it in your thing, you can see that here that resume says HP ProLine 360 G7, 380 G6, DL385 G1, DL385 G2, something like that. If it's mentioned, there is a reason for it. So at least these many models you should know. You don't need to know inside of it, but at least the names you should know, and stick with it confidently and tell it correctly. It's not 586, 585. There is no 86, 80 and 85. And then comes the blade servers. I'll give you a quick overview of blade servers, which is very important when you are a VMware guy. Probably you may want to look at some blade servers. Blade servers are, there is a lot we can talk. There is actually a whole lot of documentations and videos and all is available. Please spend some time. I'm just giving you some general idea. So let me see where I can show you. Okay, so when it comes to blade servers, HP blade servers, HP has actually, in order to put blade servers, let me show you a picture here. Okay, so this is actually a fully loaded HP C7000 blade enclosure with blade servers inside. And this is actually, this saves a lot of space. You're talking about 16 servers in this particular box. Actually, what you're seeing is actually this is very costly stuff. So this is actually called as a whole blade enclosure. I'm not going to get into this in detail, guys, because we don't have time, and I think you have to understand. But if you have questions, come back. I'll talk about it. But few things I wanted to mention. Please take a note of this thing. This is how it's called. And if you go to YouTube, you can see a lot of videos about how to insert these blades and things like that. This is actually called a blade server. This what you're seeing is one blade server. These are two blade servers popped out of it. You can pull them in. These are the power supplies. And there is a small LCD monitor here. You can do certain things, but normally nobody goes here. These servers will be in your data centers. You will be managing them completely from remotely. The backside of this chassis or the backside of this whole box is very complicated stuff. It has network cards. It has fiber channel cards, fiber optic cards, MDS switches, and it has some management interfaces. Pass-through modules, a lot of things will be there on the back of it, and the fans also, cooling. So this is actually a chassis, and inside the chassis there is a lot of blades you can put. Okay, so take a look at it. So this is HP has actually two types of chassis, C7000 and C3000. 3000 is, I don't know, maybe small companies probably may be using, so I don't think you need to worry about it. You just tell, you're familiar with HP's C7000 chassis. Trying to see a picture here. Hold on a second. Okay, so guys, this is actually the chassis. This is how it look like. I think I will show you something else. Can you see this video? Okay, look at this. This is an empty chassis. This is how it is. That thing what you're seeing inside is called as the mid plane. That is where it is getting connected. It's all copper, high-end technology. And this is the front of a chassis, and that is the back of a chassis. You see that the back of a chassis, you can see see all the fans and the interconnect modules. That's what it is called as interconnect modules. And then you put individual blades or blade servers inside this chassis. Okay. So if you go here, so in order to manage the HP C7000 chassis, there is actually a web-based tool, and that is actually called as the onboard administrator. I'm just going through something to show you here. Maybe you guys can definitely read this if you're interested. There is a lot of things. I just put it on the chat window, guys. So this is actually this picture will give you how to connect this document. Let me show you one thing here. This is how a chassis look like. When you connect through a onboard administrator, this is a web-based interface. You can see a HP enclosure and all the blade servers inside it. This is actually it will show you like a photocopy of your original server. This is the front and this is the back side of this particular chassis. I don't know whatever they are showing. They are showing a chassis information here, and then these are some slots that are empty. These all slots are filled. This is one blade, this is another blade, this is blade. These are all different blade servers. And this is the back side of the chassis, and there are some slots empty. But you can see that there are some networking slots, and all these things are the individual modules. So in the back of this module, there is a card. Actually, it's a module. It is called as onboard administrator. Typically, in big environments, you can see that every chassis will have two onboard administrators. If one goes, the other one will be the secondary, can be used. So onboard administrator is where you are actually connecting. So when you say this link, you're actually connecting to the back of the onboard administrator, and you're seeing all these things. So if somebody asks you how you manage your HP chassis, the answer is you manage it using the onboard administrator. And this is the document for onboard administrator. I mean, I'm not saying you to understand, but if you are really curious to see how it is, how you work on a HP chassis, and you want to see the different parts, how do you connect all this, everything is clearly mentioned in this document, okay? So this is the HP C7000 chassis, guys. So definitely get used to that and try to understand those things, okay? And then it comes to the HP blade servers. I just want to quickly show. So when it comes to blade servers, the name changed to BL. I heard Fanny was saying about 460s and all. There are different series again. 200 series blade servers, 400 and 600 series blade servers are available. Let's take, there are two types of blade servers. Typically, they are called as a full height blades and half height blades. This is actually a full height blade. When I say full height blade means it will take the two sections of a chassis. So that means, here is the thing you need to understand. You can put only 8 full height blades on a C7000 chassis, whereas you can put 16 half height blades in a C7000 chassis. Okay, 8 full or 16 half. This is a full height blade server. It is how it looks like. This is a full height. A half height blade is only going to be only the half of that. Let me show you here. This is actually a half height blade. These are all half-height blades. See, that is a half-height blade, and the one I showed you earlier was a full-height blade. See the difference? One is taller and the other one. So if you are using these blades, you can put 16 of them in a chassis, and if you are using this, you can put only 8 of them. Now again, when it comes to the blade servers, there are different models. There is a whole lot of models are there. Again, they have the Gen 8s and they have the G7s also, and they are also in AMD and Intel flavors. You get it, all these things. So you can look at that, and you can see the different combinations. Some of them, see, for example, you take this particular model, a 420C. It can have 2 or this much processors. I mean, these are all same. It can only support 2 sockets, but I'm just saying. So depending on the model, you may be able to put more CPU. Sometimes maybe you will have more memory slots, things like that. And you can see that the maximum memory in this one, you can only put up to 384 GB memory. Whereas if you buy this, you can put up to 512 GB memory. You see that? So depending on some models, you can add, you can have more memory and more CPUs and things like that. That's the case with other stuff also. Okay. So please, those who are not familiar with HP servers, I strongly recommend you to go through this HP server site and go through this. And if you have questions, come back to me. But definitely spend some time. You don't need to by heart anything, but just read and look at it with an interest in your mind. That's all enough. And at least note down some names. You don't need to do 10, 2 or 3 blade servers, and probably 3 or 4 rack mount DL300 series servers is good enough. That's enough for you. And maybe if you're really interested, you can go to Dell and IBM and maybe note down few numbers also. That's enough. You don't need to do many other servers. There are other servers, but typically these are good enough to put it on your resume. Any questions here? Okay, moving forward, guys. We have not much. Today is actually the 3rd class, and we haven't even started. We haven't started even doing anything here. So now coming to these HP servers. When it comes to this HP servers, how do you manage these servers? Now, for example, all my servers are here. So when you have these HP servers, you have to have some mechanism to connect to these HP servers remotely. If the servers are powered on, for example, that my Windows server was up and running, you are all able to RDP to that server, correct? When you give that IP address and your username and password, you are able to connect to that server. Fine. But what you would have done if that server was completely powered off? Will you be able to connect and power on? How can you connect to a server that is powered off? Will you be able to do it? You cannot, correct? So that is not possible in HP servers or Dell servers. I'm working from my New Jersey office, or maybe I'm working from my home. My servers are in London or maybe in Hong Kong. And if that server is powered off in the night, how do I power it on? So in order to manage these servers remotely, every server has some kind of a mechanism on the back to connect and manage it remotely. Dell servers have some technique, HP servers have some technique, IBM servers has their own technique. HP server has as a module, as a network card on the back of every HP server. There is a small module. It's actually a small EPROM there with a network card, which is called as ILO, integrated lights out. That is actually a technology, and this technology has improved a lot. What we are going to see in our class is going to be a little slow problem because it is an old model. The ILO was earlier called as RIB. That is what Sri is saying. It was actually called as Remote Inside Board. Then later it has changed to RILO, then to ILO, and now it is ILO. ILO has different versions, 1, 2, 3, and now the latest is actually ILO 4, which is coming up with the Gen 8 servers. ILO has improved a lot. That is like one of the HP's what do you call prestigious product. Actually, it's very powerful, and now with the latest version of ILO 4, it's actually really powerful. It can do a lot more things with it. Dell has the same techniques. Dell is something called as DRAC, D-R-A-C, DRAC, Dell Remote Access Card. That is what it is called as. I don't know what is called for IBM. I think somebody was mentioning earlier IBM has something. I think it's called as remote card something. But anyway, all these servers by default come with some kind of a mechanism to manage them remotely. And there is a cost associated with it also. It's not free. You have to get some license to do it. For example, ILO, if you want to use ILO, you have to have license. You cannot use ILO without certain licenses. So you have to purchase that license as part of your purchase of your server hardware. And there is a price, I think around $1,000 or something, and with the support and all, there is a license required for ILO. So let us go to one of my server, and I will show you ILO, how it is ILO. If you are not familiar with ILO, I would encourage you to connect to my servers and try to explore it. I'm not going to talk. I'm going to give you a overall idea about how to work on HP server. So as I said, every server has a card on the back which is actually connected to the network. There is a network card, and that is configured with an IP address. I will show you how to do that. So even though the server is powered off, as long as the server's motherboard is having a battery, that power is enough to connect to ILO. So the servers are down. Let me go to one of my servers, which is having, every server is configured with IP. I told you in my lab, all my IP addresses are 10.10.10.x subnet. So I'm going to go to one of my server. This is actually a integrated ILO Live 2. This is one of my HP server. It is called as integrated live. What I'm seeing now is basically this is the IP address of my ILO card. I connected to the ILO through the back, through a web browser, and I am seeing this screen. In order to connect and get into the server, you have to provide username and password. The username is administrator. Remember, case sensitive. The usernames are case sensitive. In this particular case, the capital A has to be capital A. If you type small administrator, it's not going to work. And the password is password. And you will get into the integrated lights out properties. You can see that that particular server is currently off. If I want, I can press, but this is just like, just imagine now you are in front of your server and you want to power on a server or power on your laptop. What do? You just press the button on the power button. Same way, if I press this button now with this mouse, the server is going to be powered on. It is currently powered on. Every server has a small red light, blue light to indicate when you are in a rack, when you are in a data center, hundreds and thousands of servers, you don't know which server you are working. And if you want to, make a light to blink so that somebody can go and take a physical look at it, this is that light. You can actually turn on that. So you can see that that blue light will turn on. There is a light on the front of every server. That light will turn on by doing that. Now, if you have a server and you have a monitor and keyboard connected to it, you can see the console of the server, correct? The BIOS and all. Through ILO, how do you see that? To see that through the ILO, you have to go to this remote console. When you go to remote console, these are some new things. This is actually using the .NET framework feature. I have some problem with that. I'm not going to get into that, but there is also a Java applet here. So you can click on the remote console. You can do this or you can do that. This feature started with ILO 2 onward. This should work, but I'm seeing that there is some flickering on. That's my IE problem, I think. Anyway, I'm going to go through the service console, remote console thing here. You can see that this is the console of the thing. This is exactly your monitor of. There is no video. The server is currently powered off. Okay, let me show you here. The server is currently powered off, right? Now I'm going to start this server. This server is powered on. This is exactly, guys, you need to do when you are doing my lab here, okay? Go to the Power Management tab and you say momentary press. You can just do a press button here and say OK, and you can see that now the server is starting here. Watch for it now. There you go, the server is started. Okay, so this is an HP ProLine server. The server is starting. You have to be, click your mouse. There is something you need to be familiar with. Those who are not familiar with, that's why I'm telling for people who are not worked on these things. So please look into this carefully. Okay, make sure your mouse pointer is inside. And now the server is booting. It has a 4 GB RAM. It has 2 processors. And here you can see that there is an option F8 to press thing. I press that F8 button. Guys, this is where it is actually configured the ILO IP address is configured here. You don't need to do this, but I'm telling you, when you buy a server for the first time and when your data center guy go and rack that server, he is supposed to get in here and come to this network properties here, and he has to configure it with this IP address. And then he will give you the IP address. Then you can connect and manage using this. Without doing that, nobody can connect to an ILO. Okay, so an ILO is actually configured using this. You don't need to do that. When the server boots up, you press F8 to get into the ILO properties. You can do more things, but whatever you can do from here, actually you can do from this console also. The server is going to continue to boot. This is what a smart array controller. This server has an array controller. I'm going to press another F8 here. That F8 takes me to the RAID controller. Every HP server has a controller card that manages the hard drives. These servers, this server, I don't know how many hard disks is there. You can typically put 8 hard disks in this model server. I think I have 2 or 4. I'm not sure. We have to look into it. I have a couple of servers, G2s, DL385 G2s here. So HP Smart Array 400. This is not a new, but it is a pretty new card. But there are even older cards. But that is a RAID card, and this is called as hardware RAID. People who are not familiar with the RAID, definitely I recommend you to go and understand about RAID technologies. RAID and all, you guys know RAID, right? Do I need to talk about that? I think everybody knows here. If you don't know, talk to me personally, then I will explain it. What a RAID is, redundant array of inexpensive or independent disks. You need to understand how it is and how to create RAID, but I'll show you some stuff here. So this is actually an HP Smart Array P400 controller. So if you go here and you go to view logical drive, you can see that it is actually configured with the RAID 1. I think this is only having 2 drives. It is configured with the RAID 1. Let me go and delete that. So now basically I removed all the disks, everything, the RAID configuration I got. This is how I'm going to create a RAID. I'm just showing you how to do this on a server. If you click on that, you can see that in this particular server I only have 2 drives. I have 2 146 GB drives here. Now when I have 2 146 GB drives, I can create either a RAID 1 or a RAID 0. Guys, I'm not going to talk about RAID here. I think most of you guys know RAID. Maybe 1 or 2 people may not know RAID. Let me do one thing here. So this is a beautiful site that will actually help you to learn and understand about different RAID. I will put you this site in the link. Please spend some time and then come back with questions. Don't come back to me without Deepu, what is RAID 5? Don't ask me. Read about it and then come back and I can explain you this. I know Raiden, you may not know it, and Byron, you both may not know it, but come back to me with your questions. I will explain it. Okay? Sujan, I don't know whether you may be all knowing Sujan, Sri, and you guys all definitely know it. Sri, I'm sure, but Fanny, you also familiar with all RAID technologies, right? And then it comes to Satya, I think Samrat, both of you guys are SAM guys, you definitely know. So guys, definitely try to understand. This is a good site. You can go and read about, the beauty of this is, here you can see RAID 5. You click on this, it will exactly show you how RAID 5 works. You can see that the blocks are coming, how RAID 5 is created. This is a beautiful site that explains how really RAID 5 works. You can look at the properties of RAID, the characteristics, the advantages of it, where it can be used, things like that. When you go for interview, definitely, guys, believe me, 90% time people will ask you, if the guy who is interviewing you is knowledgeable enough, he will ask you RAID. He will ask you the difference between different RAID. So my thing is, at least try to understand about RAID 1, RAID 0, RAID 5, and RAID 10. At least these 4 RAIDs you should know. You don't need to know about RAID 50 and RAID 5, RAID 3 and RAID 4 and all. But definitely understand what is RAID 0, what are the advantages of it, what are the disadvantages of it, where it is used, what type of situations it can be used. Everything is mentioned here. Disadvantages is mentioned there, the advantages are mentioned here, and the recommended applications and in what kind of situations you can use RAID 0. When it comes to RAID 1, how does it look like? Is it actually mirroring? So how this mirroring works? You may also go to Wikipedia. It has a much more better explanations with much more better pictures are there. RAID is redundant array of independent disks. It's very, very, very important. If you are going to be a VMware or a system administrator, absolutely you should know that in depth. And it is very important because when you are a VMware administrator, you may want to talk to your storage guys and you may want to discuss about what type of LANs he is providing. Is it a RAID 5 or is it a RAID 10 and things like that. RAID 10 is probably very good for high read write intensive databases. You may want to see how that is configured. So RAID 10, RAID 5, 1 and 0. 4 RAIDs. Definitely read about it. Try to understand about it. And there are other links also. Okay. So here what I'm going to do is I have 2 hard disks in this server, and by default it automatically selected RAID 1. The RAID 1 plus 0 means if I had 4, it would have configured it as RAID 10, but since I only have 2, it's going to configure with RAID 1. I cannot use RAID 5. Why can't I use RAID 5? If you read that, you will understand. Those who know, they know why it is not possible. Because RAID 5 requires a minimum of 3 disks. Fanny, let me ask you a question. Do you know how to calculate the size of a RAID 5 volume? Do you know the formula to do that? Here is my question to Fanny. I have 3 hard disks and each one is 100 GB in size. What will be my effective volume size? If I make a RAID 5 partition using these 3 disks. I have 3 hard drives. Each one is 100 GB. And I'm going to make a RAID 5 volume out of it. This one, this is my RAID 5 volume I'm going to create. What will be the effective volume of the size of this volume? Fanny, you there?
Yeah, so not really sure. Give me one second.
Okay, that is RAID 5. Okay, this is RAID 5 I'm talking about. RAID 5. What if it is RAID 0? Can anybody tell me? If it is RAID 0, what will be the case? Okay, so whatever the number 3 typed is absolutely correct. If it is RAID 0, it is going to be 300. It is actually striping. It's actually the sum of all those disks together. If it is RAID 5, it is actually, there is a formula to do that. That formula is actually n minus, it's actually n minus 1 into the size of the smallest drive. When it is all 100 GB, it's more easy. Okay, I'll tell you now. So if it is n minus 1 into size of the smallest drive, means let us see where n is the number of drives. So how many drives are there in this case? So it is 3 minus 1, correct, into the size of the smallest drive. What is the size of the drive? What is the size of the drive, guys? 100 GB, correct? Which is equal to 200 GB. You getting what I'm trying to tell you? So this is how you calculate the RAID 5 size. N minus 1 into the size of the smallest drive. I will tell you why that is. Let us say I have 3 drives, one with 50 GB, second one with 30 GB, and third one with 10 GB. What will be my effective volume size? Can you tell me? This is 50 GB, this is 30 GB, and this is thing. What will be my size of this thing? Satya is saying 20 GB. How you got 20 GB? It's easy calculation, right? 3 minus 1 into the last size of your smallest drive. That, because that's how it is, you understand that is. So anyway, I was just spending some quick time to understand this. You understand all these things when you read about it. I don't think I should be teaching all these RAID things, but I was quickly going through this. These are all important things. If I know majority of the students in this class know this, that's why I didn't spend time. Normally I teach this in detail, but I think these are some things at least you guys should know. What is RAID 5, what is RAID, things like that. So same thing, guys. RAID 1 is very important. RAID 1 is very, very important technology. Typically every operating system is typically installed on a RAID 1 volume. RAID 1 is called as disk mirroring. So that means if you have 200 GB drives, and when you mirror these, you get a single volume which will be the size of a mirror. That means it's actually a mirror. Whatever you write to this disk will be mirror. So your effective usable space is only 100 GB. So in RAID 1 is the one of the technology that has high amount of redundancy. That means if one disk fails, you are still good because the other disk has a mirror of it. So even if one disk lost, you have a complete copy on the other disk. But the disadvantage of that is you lose 50% of your total storage just for keeping that copy. So the data loss is much more there. The storage space wastage is much more, but it gives you the highest redundancy. RAID 10 is even one step ahead of it. I'm not going to get into that, but you read about it. RAID 1 is the best thing if you want more space. If you have 300 GB drives, your total space will be 300 GB. It is a sum of all the 3 drives. Great for read applications. Everything is good, but if one drive fails, everything will go. There is no redundancy for it. RAID 0 can be made from 2 to 32 drives. RAID 5, you need a minimum of 3 drives to create RAID 5, and you can go up to a maximum of 32 drives. Okay? So please read about that, guys. So that is RAID technology. So I'm going to make a RAID 1 partition here. I have selected. You can use the space bar to select and unselect drives if you want. So you can press the space bar and the up arrow. You can select the drive. So I selected both the drives. I can make a RAID 0 or RAID 1. I'll show you the difference here. Now I'm going to make a RAID 0. Look at this mouse pointer. I'm going to create a RAID 0. If I do that to 146 GB drives, I can see a sum of the total volume size. The logical drive I'm going to create using that 2 physical hard drives, 146, is actually 273 GB. May I ask you another question here? 2 146 GB drives, right? Look here, that is 146.8 GB. That is the size of a drive. What is the sum of that? 2. 146 into 2 is how much? How much is 140? 293, correct? Okay. So if you using RAID, if you are using, oh come on, if you are using RAID 0, that means it should be the sum of these two, correct? Then it should be showing 293 GB here, but it is showing only 273 GB. Why is that? I'm supposed to see 293 GB. Why is it showing only 273? Memory info. Not memory info. Actually, that space is used to write the metadata information. That metadata information means when you do that RAID partition, the information for that RAID creation, there is some metadata information. Is that information is actually stored in that location. That's why you don't see that full space. So certain space is reserved by the RAID to store its configuration information. That's called the metadata information, and that's why you don't see that. So you can create it like this, or you can create a RAID 1. See, when I say RAID 1, it's going to be a mirror. So you can see that now I get only an effective space of 136. Again, you lose almost 10 GB there because to write that metadata information. So I'm going to press F8. I'm going to create a RAID 1 volume. So I'm pressing F8 to confirm. And I created the drive. Press enter. Now if I go to create logical drive, you can see that there are no more drives available because there are 2 drives and I already used both of them. Now if you go to view logical drives, you can see the 2 logical drives there. You can see that these are the 2 drives. It shows the logical drive 1, it's RAID 1. Total size is this, and it consists of 2 physical drives. So this is another thing. You use 2 physical drives to create a logical drive. So whatever you create using the RAID is called as a logical drive, and the physical drives are called as physical drives itself. Is that clear? So guys, you can connect to the servers. I don't think I'm going to stop it here because I don't think it's a good practice to go past 10:30. It's already time is running out. I don't think I can install today. I thought of doing ESX4 installation today, but unfortunately I think we don't have time to do that. We will do it tomorrow's class. Now, what I think we will do the installation now, guys. I will just show you so that you guys can practice it tomorrow. So I'm going to create this. I'm going to escape. I created that. The server is now continue to boot. Is it going to boot? Let me just, I know I'm doing it a little fast, but we can repeat this tomorrow again. Those who know already HP servers probably may know how to do it. It's already 10:36. I think guys, we will stop here today. I don't think it takes time. I don't think I can do that fast. So that's fine. So I'm not going to do that. So this is the server. What I want you guys to do is, I have servers like this. These are G2 servers, but I have I have different servers here. You can go to 10.10.18. That is an old server. This will have more number of drives. So anybody wants to practice RAID 5, please go to these servers. You can use your remote desktop from your desktop. So go to there and then connect to these servers, log into these servers, go to the power button, virtual power button. So it's logged off. So every server, the username is administrator and password is the simple small letter passwords. Okay, if you type it wrong, it's going to be a problem. So go to you can actually try from servers. These are all different servers. You can try 16, 17, 10.10.17, 10.10.16, 10.10.19, and 10.10.18. Please use only these servers. There are other servers that are running some information, so don't connect to that servers. I don't think you have access to it, but please don't try to connect even if. So only try to connect servers 16, 17, 18, and 19. These 4 servers, whenever you get time, connect to these servers, log in like this, and go to the remote console. Dual cursor or anything is fine. It will come up. You have to be patient enough. This ILO is not a very interesting thing. It is actually very slow. So be very patient on it. It's not that because you're connecting remotely or anything. This is how it is. Even in your office, you're going to see the same problem. So be patient on it. It requires some Java applets to be loaded. So be very patient to it. It will come up. So this is the remote console. You go to the power button and you can see that the server is currently off. You can press the virtual power button and say OK, and it will start the server. You can see that the Java thing is coming up. You can say always trust the connection and say OK, and you can see that the server is booting now. See, that server is starting. This server again the same concept. Everything is same. Make sure if you want to pass some commands or something, press the button inside of this. You keep your mouse active inside, and when it comes to the smart array controller, you plus F8. You can get on to. Yes, that's correct, Raiden. Administrator and password is password. That's correct. It's all small letter password and administrator with a capital A. Okay, this is a server with 16 GB RAM, 2 processors. It is going to load. This is a DL385G1 server. Wait for it to come. When the RAID controller come, I'll show you. Don't worry about this power supply failure. There is only one power supply connected. That's why. This is that integrated lights out. Now you can see that I'm pressing F8. I got into the RAID controller. If you go to the logical drive here, this one also has. This is actually somebody has created a RAID 5 volume. This has 4 drives in it. They made 4 36 GB drives and they made a RAID 5 out of it. So you do the math, n-1 into the size of the thing, you will get this number. But again, not this correct number. You remember there is some space will be reserved for the metadata information. Press escape, go through this and get used to it. Okay. What is the fan score? Is it possible for you to record this so that we can go faster instead? That way we will save some time. Record for what? Fanny. I mean, I told you, I think I told you in the first class itself, I cannot record any sessions. If anybody wants to record.
No. I mean, no, I mean the installation of the ESX. I'm thinking probably because I do installations of Hyper-V every day. It takes about 45 minutes for me to do it. So I'm thinking if we cannot wait 45 minutes, right? So if we can record and maybe fast forward the part where it installs and stuff like that.
That's a good idea. I think I should think about that. At this point, Fanny, I don't have any recording. But tomorrow what I'm planning is, we went through this disk configuration, everything. We can start the installation, and once it starts the battery, you can see that in the background, and I can talk something else. Probably we'll start discussion about some ESXi installation. Meantime, and again, as I said, I'm not planning to teach too much about ESX since you guys wanted to see ESX server. My purpose here is to show how to install ESX server, give you guys a chance to install ESX server and get a little bit familiarized with it. But I'm not going to teach anything more on the ESX servers side of things. But just like that, I understand your thing. What that's a good session. I think next batch onwards probably I should do that. Okay. So please, guys, whoever wants, get used to these servers. I know this is maybe boring for some people who know it, but guys, understand that there are people who don't know this. So I have to go through this as part of the class, and we will start the installation tomorrow. Okay, and there is class tomorrow. Let me tell you one more thing here. Today at least. So today is 20th. There is class tomorrow. And there is class on Sunday. You know that Sunday we have a longer session from 2 o'clock in the afternoon to probably around 6 o'clock. That will be a long session and we might cover a lot of topics there. Next week, I'm going to have a class on Monday and Tuesday again. So that means there will be 3 consecutive, or probably I may not have a class on Monday. I will instead I will think about it. I have some work also coming up in my office, which I may have to stay late on Wednesday for sure. So Tuesday, Thursday, Friday, and Sunday, something like that I have to do. The reason I'm telling you is when it comes to October, this week, Friday, Saturday, and Sunday, I'm out of station. I'm actually in South Carolina, so there is no class. So anybody wants to plan something, please do like this. Okay, this is very important. I need to tell. So I will have classes on these weekdays for sure. There is no class on October 5th, 6th, and 7th, as well as on 12th, 13th, and 14th, because I'm out those 3 weekends for sure. So that's the thing. So there is no see, Sujan, that's why Sunday class, I know you cannot attend, but I cannot do anything. There are no Sunday classes these 2 weeks, but this coming week and next week, there is definitely classes on Sunday. Okay. So please adjust your timing however you want to. Otherwise, you talk to one of your colleagues and get it recorded. But there will be classes on these 2 Sunday and Saturday. Maybe a Saturday I will see that, maybe 29 Saturday. I know there are some people having Saturday problem, but it is something like a give and take. We have to adjust. But we will have classes more on the weekdays, guys. Okay. So my plan is to finish off this class probably by 20th. I hope I will be able to finish it by this 20th because I'm losing some weeks here. But by 20th or by mid of this week, I should be able to finish because that much time is required. There's a lot of things to cover, and you know that we haven't even started the stuff. Okay. So please plan accordingly. The first and second week of October weekends there is no class. Friday, Saturday, Sunday I'm not here. So if you want, you can plan things like that accordingly. I will send you the meeting details for the next 2 weeks this weekend. So guys, I'm stopping here. Any other questions? Anybody has any questions, any suggestions or anything?
Yeah, Arvind here, Deepu.
Yeah.
Actually, I'm trying to connect to this ILO using these IP addresses. Either using the RDP or through the HTTPS, it doesn't. How do you go for it?
Okay, hold on. Okay, can you share? What is that? Satya, can you send me your password in a private message to me, please?
No, this is Arvind.
Yeah, okay, sorry, Arvind, okay, that's fine, Arvind. Let me see, where is you? I don't see you here, Arvind.
Okay.
Okay, let me do one thing, Arvind.